Hello guys, in this lecture I would like to explain about the differences between one of the most important topic in statistics, one of the most important topics in statistics, correlation analysis and regression analysis. Some of the people use these two concepts interchangeably, which is not the case. They are quite obvious differences. There are clear differences between regression analysis and correlation. You need to deal with different problem by using these concepts. So in this lecture, I have some points and there I will like to explain that in which situation you will use correlation analysis and which situation you will use regression analysis. I hope that this will help you to clear your concept. Let's move to the lecture. Okay, so these are some points which I wrote. Let's start from the first point, correlation. Correlation is the statistical measures which determine the relationship or the association between the variables. Regression describe how an independent variable is numerically related to the dependent variable. Let's explain this now, how we can do this. You can see that in correlation, we just find the difference. In correlation, just calculate the relationship between the two variables. You can see again the relationship between the two variables. The relation, the relationship or association or association between variable. I will not talk about between two or more variables. Between variables, I will just write like this. Maybe two or more, you can say. So this means that we cannot say that there is dependent variable and there is independent variable. I'll explain this in the next point. In regression and regression analysis, indicate the influence of the independent variable or variables on the dependent variable. On the dependent variables, variable or variables. So this is quite obvious that these two things are different. In one case, we just try to calculate the relationship between the two variables. We are not talking about any dependent and independent variable. That is correlation. In regression analysis, we talk about that one is dependent variable which is affected by the independent variable. Independent variable is not affected by the dependent variable, remember. Second point is no difference between variables. This is also covered in the first point, but it is explicitly mentioned here. So no difference between variables. I mean that there is no dependent and independent variable in correlation analysis. In regression analysis, one is dependent and other is independent variable if we are talking about simple linear regression model, SLRM. The number of dependent and independent variables can be more than one. In that case, we say that is multivariate regression model. Okay, so this is the second difference. The third one is correlation coefficient indicate the extent to which the two variables move together. Let me explain this first. Okay, let me write the two variables. There are two variables, so just write like this: x, y, x, y, x, y. Remember that in correlation there is no concept of dependent and independent. So we can write x, y interchangeable is no issue. If the data is look like this is this mean that what is mean by this? Because I'm explaining that point that it's the extent that how the two variables move together, the extent that the two variable move together. So this means that both variable move in the same direction, increasing, both variable increasing. This means that this correlation is close to 1. The correlation coefficient, the value of the correlation coefficient is close to 1. If there is this data is looking like, this means that yes, both variables are moving the same direction. And if the cases look like this, if the data is look like this, something like this, what does mean by this? This means that x increasing, y decreasing. This means that one variable move in one direction and the other is moving in the other direction. The variables are moving in the opposite direction. This means that this correlation, the value of correlation coefficient is close to -1. You can write +1 here just for the difference. Not necessarily we don't write, but this is okay. And if the data is something like this, there is no clear pattern, then we can say the correlation coefficient. I will not write exactly 0, but you can say the correlation coefficient is approximately equal to 0 in this case, because the variable, there is no clear pattern the variable is moving, how the variable are closely moving. So this is the interpretation of this point. This point, regression indicate an impact of a unit change in the known variable x and the estimated variable y. Okay, now you can just write simple linear regression model. This is dependent variable, this is intercept plus beta x, and you can write the error term as well, plus this is the epsilon. So you can calculate dy is equal to, with respect to dx, change in y with respect to x, this should be beta plus 0. So this means that what is beta? That is equal to dy divided by dx. And by definition, this is the change in the dependent variable per unit change in the independent variable. Okay, so this is something different. This regression coefficient show that the change in the dependent variable as per unit change in the independent variable. This is different. And the correlation coefficient is some ways that is the relationship. So this is the third point. Now the fourth point is to find the numerical value expressing the relationship between variables, to estimate the value of random variable on the basis of the values of the fixed variable. Okay. In correlation analysis, what we do, in correlation, we calculate just the value of R. What is the numerical value? This can be whatever. This range, I will like to write. The range of the correlation coefficient is from -1 to +1, whereas -1, +1 and -1 has their own meaning. Perfect positive correlation, positive relationship, or positive correlation. I mean that both variables are clearly moving in the same direction. It is not necessary that the two variables are moving increasing. It may be necessary that if two variables are decreasing together, then this is also a positive correlation. And this is perfect negative correlation. Negative, and the value is lying between this one. And there is no such range for for the regression coefficient. It can be greater than zero, but with different sign. Let's suppose I would like to explain this. Suppose y is equal to alpha plus beta x. Suppose this is the estimated equation. There are two scenarios. Y is equal to suppose 50 plus 0.5 beta, x, not beta, sorry. This should be x. And the other equation is suppose, I'm just explaining, 50 minus 0.5 x. So this means that the value of beta as this one, but with the sign is positive, and this means that the value of beta as 0.5 with the negative sign. These two has different interpretation. This means that there is changes the that the dependent variable depend on the independent variable, or the independent variable has the influence on y positively. This means that the independent variable has influence on the y negatively. So you need to interpret this parameter correctly. Okay. Okay. So this was about the correlation, and now what we do with the regression, that's more important. With the correlation, you cannot do prediction. With the correlation, you cannot do prediction. With regression, with the regression, you can do prediction. How? Because correlation is just the strength of the relationship between the variables. And you see that you can see that this is alpha plus beta x. These are the estimated values. Let's suppose alpha in the above equation is 50.0, and beta is suppose 0.5. This means that this is equal to 50 plus 0.5 x. You know, you have all the things on this side, alpha, beta, and x. If suppose you have the value of x that is called independent variable, suppose this is, you can say 2, you can predict the next value. Suppose this is, you can say 10th, just for example. So this value is equal to the next value is suppose that is 50 plus 0.5 multiplied by 2. This is equal to 51. So you can do prediction with the regression. You cannot do prediction with y. This is the most important difference. So if you have problem like this, you can use correlation, regression, not correlation. Okay. Now the last point, which is very important, I would like to discuss about this. Correlation is symmetric. Correlation coefficient is symmetric, and regression coefficient is not necessarily symmetric. I would like to explain this here. Correlation coefficient is symmetric. This means that if you calculate between x, y, or you calculate correlation between y and x, both are same. Simple. This is just this natural that if the correlation between x and y is supposed to, suppose this value is 2, not 2, because the range is between, this is suppose 0.90. This is quite obvious. This will be quite obvious in 0.90, because this is the relationship between these two variables. On the other hand, regression coefficient may not necessarily be symmetric. This means that is equal to alpha plus beta x. Suppose this is the estimated equation, and suppose if I'm calculating, this is not true. It's maybe not true that x is the dependent variable, but this is now the relationship. I mean that the dependence of y on x, that's that amount. So it is not necessary that x depend on y in the same way. So correlation coefficient is symmetric and regression coefficient may not necessarily be symmetric. So these are all the differences between regression and correlation, and I hope that this will help to clear your concept about the applications of regression and correlation in your research and other problems. If you like the content of the channel, please subscribe the channel and see you in the next videos. Ciao.